Hello all, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the today's lecture. Okay, uh, chapter is first order ordinary differential equation, and today's lecture is same as previous, that non-exact differential equation. That means to finding the integrating factor. This is part 3. That means in part 1 we have two method 1 2. In part 2 we have another two method, and in this part 3 we have method number 5 and method number 6. So let's start with the method number 5. So if m dx plus n dy is equal to 0 is not exact, but it is of the form, this form, that x raised to a y raised to b outside of the bracket, in the bracket m y dx plus n x dy plus x raised to c y raised to d into bracket m y dx, sorry, q m, that is p y dx plus q x dy is equal to 0. Here this a, b, m, n, c, d, p, q are numbers, that means constant. Okay, so no need to worry about this. The constant may be anything, 0, 1, 2, 3, 4, any. Okay, then if will be this x raised to h y raised to k, and here h and k are also constant. For that you have to check that given differential equation is can be written in this form. Okay, so we'll understand this with one example. So we have this example: solve y cube minus 2yx square dx plus 2xy square minus x cube dy. Here at the first look you can observe that this example is looking like homogeneous, degree 3, degree 3, degree 3, degree 3. So if you want to try with homogeneous, then you can try. Whatever will be the answer is also considered as a correct answer. But here I want to just explain you method number 4, so I am just using method number 5 for this example. So we have, this is m, this is n. If we differentiate m partially with respect to y and differentiate n partially with respect to x, so we have these two, and both are not equal. So that therefore given differential equation is not exact. Now it is not exact, then it is method number 1, that means homogeneous. Yes, so you can solve by that method only. Okay, or it is of the form that xy function of xy, y dx function of xy, x dy, then you can solve by that method. Or difference of these two is divisible by any of these two, m or n, then you can use previous lecture, that means method number 3 and method number 4. Now I am just following with method number 5. So I'm just expanding this bracket. So y cube dx minus 2yx square dx 2xy square dy minus x cube dy is equal to 0. I'm just taking these two terms together, so we can take y square common. Okay, so just taking together these two terms, and I'm just taking these two terms together minus outside, so both plus. Now we will take common. So from here we can take common y square. So we have y dx and 2x dy. So we can write like x raised to 0, because we need this form. This form, we need this form, which is already I have just given in method number 5. Okay, here a and b are constant, so a is 0, b is okay 2 constant, m is here, m is 1, n is this, n is 2. Okay, so match with this. And now from here if we take common x square, so we have 2y dx plus x dy is also satisfied this term. So method number 5 is applicable. And if given differential equation is not exact and in this form, that means in this form, then if is x raised to h and y raised to k. So now we will start with this if. So we will multiply this with equation number 1. What is equation number 1? This is our question. So multiply x raised to h, y raised to k to this equation, and now multiply this in bracket. So we have x raised to h as it is and y raised to k plus 3. Similar way here y raised to k plus 1, x raised to h plus 2, similar way here. So we have this term. Now this become exact because as we already told that if you multiply with if, then equation become exact. So it become exact, say equation number 2. Okay. Now if it is exact, then differentiation of this partially with respect to y should be equal to differentiation of this with partially with respect to x. So we'll differentiate this term and this term partially with respect to y and x respectively. Say m dash and n dash. So just we differentiate this term with respect to y. So x raised to h constant, and differentiation of this is k plus 3 forward and y raised to k minus k plus 2. Similar way with respect to y this term, similar way with respect to x this term. Now if we compare both the side, you can see x raised to h, y raised to k plus 2, x raised to h, y raised to k plus 2. It will come compulsory. Okay, in any example, if that example match with this method. Similarly, x raised to h plus 2, y raised to k, x raised to h plus 2, y raised to k. So we'll compare the coefficient of like power of x and y. So we have k plus 3 is equal to 2 h plus 2h plus 2. So we have this equation 2h minus k is equal to 1. In similar way, minus 2k minus 2, that means minus minus you can cancel out both sides. So 2k plus 2 is equal to h plus 3. So we have h minus 2k is equal to minus 1. By solving this, we can find the value of h and k, and the value of h and k we will put here in this equation. And now then we have the if. So this is the process to only find hk for if. Okay. So now by solving that equation, we have h is equal to 1 and k is equal to also 1. So if is xy. X raised to h, y raised to k, that is 1 1. Okay. Now equation 2 becomes, that means this equation we already multiplied, so we have to just put h and k value 1 1. So x raised to 1, y raised to 4, minus 2, x raised to 3, y raised to 2, and so on. Okay, and this become exact. And we know that if this become exact, then how to find the solution? Integrate this with respect to x, keeping y constant. Integrate this with respect to y, term free from x. So we have this, and here both the term contain x, so remove 0, and integrating with respect to y only. Okay, sorry, x only, keeping y constant. Okay, so we have x square by 2, x raised to 4 by 4. By simplifying, this is our final answer, and which is our general solution. Okay, so easy. So this is method number 5. Now, what about method number 6? This is not a particular that special step method. Like in method number 1, we have particular type that not exact, then homogeneous, then if is given by 1 upon mx plus ny. Similar way, method number 2 has a special method. Similar way, method number 3, 4, and 5 all have a special type. But in method number 6, it is given that if this is this given m dx plus n dy is not exact, then if can be obtained by inspection. So this method is known as inspection method for if. Inspection method, that means that comes by your experience and practice. If you practice previous 5 method, then you will understand how you can group the term, and your observation and experience will give you answer of if. There is no any particular formula for if in method number 6. Okay, for that, to understand some inspection, we have this table. Okay, so let's understand this table. If you will find like this term in question x dy plus y dx, you can write this as dxy. D, that is differentiation of this. So if you differentiate with respect to differentiate, simple. Okay, total derivative. So x as it is, differentiation of y is dy, plus y as it is, differentiation of x is dx, not with respect to x or y. So you will get this. So these are the exact differential. Similarly, same term is given, but there is some complication in example that you have to compulsory divide by xy. So you will get this d of ln xy. Similar way, this are the some special that you have to just note down in your notebook, and you have to check that by differentiate this you will get this term or not. This term, that means multiply by this, because this is if. Okay, so 1 upon x square plus y square into x dx plus y dy. You got or not by differentiating this term. Okay, that you have to check in your notebook rough by pausing this video. Then you will start with this example. To solve this, here we don't have any special logic or anything. So we'll start with this question. And here, by observing that, if we can take LCM, so dx multiply here and divide by dx multiply here and divide by dx, and dx cancel out from the both side. Now, if we take this term on right and left hand side and this term on the right hand side, so we get this. Now, as I told, you can see this is your d ln xy, that you have to remember. Okay, and you can write this term as a dx plus y. So suppose this is our t, this is our t, so we got dt by t square. What is the integration of this? We know that minus 1 by t, by rule of integration, simple. So instead of t we have x plus y, so we can also integrate this term. Now by integrating both sides, we have integration of this, and then like integration of dx is what? X. So integration of d ln xy is what? Ln xy, simple. So we have ln xy, and on the left hand side integration of 1 upon x plus y whole square dx plus y. As I told, this is our t square, so minus 1 by t, simple. So this is our final answer by simplifying this term. Okay, so here we didn't use any method, just we use our experience and observation from the previous method. Okay, so this is the one of the method that you have to just remember. In examination it is that not that much important, but if it is asked, that you should know the method. Okay, and you should, if you practice previous methods and example, so you can deal with this type of example also. Okay, now example number this. So we have this m, we have this n. By differentiating this, we know that both are not equal, so not exact. Now we don't have any method 1 to 5 to finding if, so we'll try to observe. If we multiply with this, so we have y dx and this, so we'll just opening this bracket, and if we take these two term, this term with dx and this term with dy together, and then e raised to x with dx and dy together, so you can see that we take x square y square common, so we have, that means divided by y square, y square, y square, y square, we have this 2x square dx y dx. So integration of this is possible with respect to x, integration of y is possible. And now this is, you can observe this, it is e raised to y x by y, differentiation of this. See, numerator as it is, differentiation of numerator minus numerator as it is, and differentiation of e raised to x dx, okay, and divided by y square. You can see, but this is first term is second, second is first, so we can take common minus, so we can write this minus of this. So we have minus of this e raised to x, okay, because we have this term, sorry, we have plus, because numerator as it is, denominator as it is, differentiation of numerator minus numerator as it is, differentiation of denominator, which is already given. If it is not given, then we can put minus. Okay, so we have this, and now we can integrate this. So by integrating, we have this, this, and this, and this is our final general solution. So here also we used our inspection, observation, and experience. Okay, based on that we have these examples. So you can find these three examples are, or these 3 or 4 examples are from method number 5, and this remaining example are from method number 6. Okay, so these are the example for method number 5 and 6, but I must say compulsory you should try each and every example of this lecture as well as previous lectures, so you will understand better about this chapter. Okay, because this chapter has a 14% weightage in GTO examination. Okay, so that's why I'm forcing you. So thank you for today's lecture, and we will see you soon with next new method. Okay, because till now we just finished our exact and non-exact differential equation, both the method. Okay, so thank you very much.